I'll do a local record for it. Okay, so welcome all, and sorry for the teething problems. CDL, April 5th, and my first in a little while. I invited Sonny Bhatia here. Sonny Bhatia just defended his master's thesis on something that I think will interest a lot of people. He's been working on creating debate maps from Pol.is data. I'll let him explain more of what he's been doing. Does anybody else have agenda items? I just invited Sony, and I think there's another agenda item, not minor. Uh, we've had complaints from Jamie that this time is rarely suitable, and I think she's not the only one. I'm happy to see Tim, but I know it's been difficult for him often to come at this time.
Yeah, for me, there's no guaranteed time right now. My life is such.
Okay, but maybe we need to revisit. Maybe we need to do another timing round. I mean, our last attempt took some. It was a while ago. It's tedious, but we may have to do another round of time estimates. Uh, Anybody else is new here? Should we do a quick round because Sunny doesn't know everybody here? Sunny is new. But let's make it quick so he gets to introduce himself. But you should start, Sunny, actually.
Okay, hi, I'm Sonny Bhatia. I've been in the space of debate mapping and just in general understanding how arguments work and all for a while. I've been working with Jack for on almost 15 years now. So been in contact with a lot of people in the space, more or less. But so I was a software engineer back in the Bay Area. Up until 2013, when I got bored out of my mind, I didn't want to be in front of a computer anymore, so I dropped that and I went and joined the army. So I did that for a couple of years. I was in the infantry, went to Afghanistan, and I had a lot of fun there. And then I was like, all right, this is great. I had adventure, so wanted to get back into technology, but stay in defense. So within the army, I commissioned as an officer, joined the cyber branch. So I've been doing that for the last 10 plus years now. I'm still in the army and having a lot of fun. But at some point, they paused what I was doing and they were like, go get your master's and go teach at West Point. So West Point is the U.S. military academy, and that's where I'm headed next. I just finished up my master's with this thesis that I did 2 days ago. So I'll discuss that and we'll get more into that. But yeah, so my next stop would be West Point. I'll be an instructor there, so I'll continue my research and be in this space. I'm hoping to see you more often.
I can dive in next, Marc Antoine, if you want. People will be passing around. So I'm Bentley Davis. Been a software developer for 30 years. Been working in the having people make better decisions and better arguments for over 10 years. So I create, I'm a contract software developer, had a startup that exited. So I'm able to donate more time towards this type of stuff without profit. And that's probably all the important stuff. Current project is Reason Tracker, and you can see the links to all of our projects on the CDL site. But yeah.
I can go next. My name is Ben, and I'm a recent graduate from Colorado School of Mines, and as of last December. And during most of my time, or during the last 2 years, I've been working on a project called Logipedia and recently, with all the AI stuff, been developing something to go and search or to find the pros and cons of different debatable topics from the interwebs and cite actual evidence rather than just like generating stuff. And recently I've joined full-time with Society Library, and so I'm super excited to apply my skills with them.
I can jump in next. Sonny, thank you for your service, first and foremost. Really appreciate that. And then I am the founding executive director of the Society Library and one of the co-founders of CDL. The Society Library works on collecting arguments, claims, and evidence to model the reasoning from different points of view on complex socio-political issues. And then we've also done a number of government-related projects. So decision-making models for local government. We've done computational legislation well before GPT 3.5 existed, and that was like very easy to at least simulate. Yeah, and the trajectory of our project could be in one direction or another, or both, which is like moving towards open source, since the sincere inquiry into truth by modeling evidence and argumentation is probably a collectively held project, or rather it needs to be. But then also we have an interest in advancing evidence-based policymaking. And so moving more in the government contractor direction is something that we're also considering. But right now we're just a 501c3 nonprofit.
I guess I could
Sorry,
go
I guess I'll
next.
go. Yeah, no.
Oh, go ahead.
I was having technical difficulties. I'm Tim. I'm one of the founders of the Canonical Debate Lab. My interest, I'm a software developer, but I was working on decision-making technologies more as a hobby, a little bit professionally before I came upon this. So like everyone else here, my interest is in creating the tools to help everybody collectively make better decisions, specifically through information architecture is kind of the angle that I've been looking at it. I don't know if you're able to talk about this or if you can get into this in your presentation, but I'd be interested to see how your work in the cyber departments of the military bring you to debate technology. I could guess, but it'd be interesting to hear what sort of perspectives you could provide on that. And one other comment I'd just like to make to the group while I'm talking is, I think this is actually a great idea going forward, as well as something that we could do periodically, is find academics. We share a lot of academic papers, right, in one of our channels here, the related papers. It'd be interesting to invite sometimes academics that are working in this area to come present their work to us. You know, most of us aren't academics, but I think it serves two purposes, which is us really getting up to speed on the latest work, and at the same time getting people familiar with our work. So I think this is a great idea, and I'm glad to have you here today, Sonny.
Marc-Antoine Parent, active in the field for many years. Et puis, what else? Worked on, mostly interested in protocols and data models for federated large-scale discussion. Could go longer, but I think let's keep it short. Jack, Michael is left.
Michael Gartner. I've been working mostly on a open source plugin for Rome Research called Discourse Graphs that takes articles and breaks them down into questions, claims, evidence, and sources. And lately I've been poking around at AI with the whole AI craze. So
Yeah, this is such a great group. I'm Jack Park. Most of you know me, but just a brief review. I did some work in the AI lab at SRI International, which it's the lab that was started by Douglas Engelbart. It's no surprise that I ended up working with Doug Engelbart for quite a while in the same era as I met Sonny when he was doing some things in the Bay Area. But I ended up meeting Jeff Conklin, who does this thing called dialogue mapping. If it's live, if you're facilitating a group meeting, or it's called issue mapping, if you take a body of text and you turn it into an IBIS graph. And I ended up doing doing a PhD project at the Open University in the UK, and I defended the thesis proposal. And the thesis proposal had to do with cleaning up, improving the signal to noise ratio of large discourse maps using topic mapping technology, which engages aspects of artificial intelligence. So I was using everything I knew. And when right after I defended the thesis proposal, I was in the Bay Area, and a CMU West professor stood up in a meeting I was in and said, "How could we have civil conversations online about politics?" And my answer to him was World of Warcraft meets global sense making. And it was on that day that we formed Topic Quest, which is now Topic Quest Foundation, a 501c3. And I've been working with Marc Antoine on what I wanted to do, which was to marry the ideas of role-playing games with structured conversation. And so we have this platform called SenseCraft, and Sonny's work applies to it. Marc Antoine's hyper-knowledge work applies to it. And my background project, Open Sherlock, applies to it. And it's this whole open source space in which we're trying to improve on the ability of humans to conduct conversations. SenseCraft comes at it from I'll just say this is the last thing. SenseCraft comes at it from a slightly different perspective. And that is this: when you are in a guild, as you are in World of Warcraft, you are learning a skill and you're leveling up. You get more cool tools, more guns, more weapons, more whatever as your scores rise. And the same effect could go on when you take people and put them in the guild and you give them a task of doing research on some topic or whatever. They are learning the skills of deep critical thinking, and they are learning the skills of civil conversation, and they're learning it inside the guild. The guild could be really noisy and ruckus and crazy, but what comes out of that guild is a contribution to a civil conversation about something that matters. And so my interest lies along two things. One is building, let's say conversation trees about matters that matter, but also building better humans. And so that's basically what's going on. I'll stop there.
Okay, we've all been through. Sonny, the floor is yours.
All right, sounds good. I'll go ahead and share my screen. I've also posted a link, and if you prefer that over screen sharing, that will work just fine as well. It'll auto increment as I move around my slides. Let's see if I'm sharing. Yep, that's it. So.
And Sonny, your audio is a bit low. I don't know if you have a chance to, maybe too late to ask you to check that.
Is it better now?
Yeah, it's a little better, yeah.
Okay. So the whole idea behind this thesis is to take a Pol.is conversation, conduct analysis, and get some policy insights. It's a very rudimentary work because I had to keep it limited in scope, had to fit within 2 semesters of thesis. I want to build upon it and do a lot more. There's a lot of ideas, but we'll start here now. So the overall context is, as Conklin defined wicked problems, he gave a singular definition. Wicked problems is what we are all trying to solve, well, not solve, but optimize. Those are problems that don't really have a clear formulation. You don't have a stopping rule. So you can't say when you solve climate change, you're working on it, and at some point it would have gotten better, but it's not something you ultimately solve. So there's no right or wrong answers, but there are optimal answers. That's what you're looking for. That's where public opinion helps. Is everyone familiar with IBIS, or should I talk about it?
I think we all know about it.
Okay.
Yes,
Yeah.
I think.
Okay. So the problem statement is, how do LLMs help us in this space? How do they help us better make sense of public opinion? These are the research questions. Most of the effort went into the first one. I do keep the risk and risk of biases, especially inside, so that we're not losing track of those. And hallucinations could be bad, so we do take a couple of steps to mitigate those, and that's what I covered in the third one. Embeddings are great because they let you do things mathematically where you don't have to really call LLM. So those have been helpful too. I'm going to skip over the related work because it's all the things that mostly everybody would be familiar with. I'm guessing. Pol.is, do we need to talk about this?
I'm familiar, very familiar with Pol.is.
Yeah, I think most of us are familiar with it.
Okay, sounds good. So the pipeline here is that we take the data, calculate embeddings. I also run a comment moderation pipeline, which is interesting. There's some cool things that come out of it, but it's not ultimately fed into topic modeling. I still stick with what Pol.is moderators determined was acceptable for the conversation. So those embeddings are fed into topic modeling. We identify themes and sub-themes. And then I have another set of language model calls where I attempt to synthesize some of the opinions, so identify the problems and solutions within the data set and generate some insights and build an argument map out of that. And then once I have a set of arguments, I do some scoring to ultimately surface the ones that have the most acceptance from the public based on the voting data. So for this data set, it's pretty straightforward. Here's the cool thing. So guidance is a very interesting framework that Microsoft put out a while ago. It's open source, it's on GitHub. It lets you constrain generation using any criteria you want to give it. You can say, generate a line, generate a sentence, or so on, whatever. But when you say stop generating at a period, it'll stop generating at a period or comma or whatever symbol you give it, whatever token you give it. You can also specify context-free grammars and say, this is exactly what I want generated. So what that does is you get to control the context very closely, the context of the LLM. You're not prompting it with a question and expecting an answer and hoping to parse that. You're not doing that. In this example on the right side, well, the code on the bottom is the input and the example on the right side is the output. In this code, everything that's given in the Python string is basically output here as is, except the portions that are highlighted in green. Those green highlights are the portions generated by the language model. So it's a lot less expensive because you're not spending time generating tokens where you already know what to expect. Now, look at the name, line 7. You ask the language model to generate with a gen. You say generate, feed it into this variable called name, and stop when you try to produce a double quote. So it starts producing spider, and as soon as it reaches a double quote, it tries to produce one and stops right there. For the age, we're giving it a regular expression. Just generate digits, and the moment you try to generate a comma, just stop producing. For the armor, we just give it a list of options. These are the 3 valid options. I want one of these, and that's it, nothing else. So this way, we produce exactly what we want. This thing helped me structure the output in a way where I could tightly control what I wanted and not have to worry about the other things. I did spend a lot of time with LangChain, try to use different libraries to, there was a JSON library that lets you specify JSON schema and then catch the output in that format. And if it matches, it'll parse it for you. If it doesn't match, it'll prompt the language model again. It was very tedious, did not work very well. So this turned out to be the best option. Moderation, I briefly mentioned, but this is just an experiment I put together to show how LLMs could do better. There's a couple of things I optimize for, use different techniques. In this one, I give it the task up top, or give it the context of the conversation, give it the task. I'm asking it to classify the given text in one of the 3 categories, accept, unsure, reject. And then asking it for reasons as well, and then ultimately giving the output format. This turned out to be the best way to get a model to generate what I wanted it to. And this is still within the guidance context, but at least I want the model to understand when I say classification, this is what I'm looking for, and so on. Here's the output. And there's a couple of different things I tried, but I'll jump forward to.
Could you go back to the output really quick? I just want to take a look at it.
Yes, yes. This one. And just want to note, this is the very first baseline test. So the output's not supposed to be great. It's just something. It's an example of how well the guidance is working, because it gives me one of the three labels: accept, unsure, reject. And once it does, I can programmatically decide what needs to happen next. So unsure means I'm asking for an explanation, but no reason. Reject, when it says reject, I ask it for a reason and then explanation and so on. If it says accept, I just move on to the next one. Any questions here? All right. I did feed the model some examples, but I did not want to make them relevant to the conversation, because the moment you do that, you're skewing the model's output by telling it what should be accepted or shouldn't be accepted. So I didn't want to use anything specific to the conversation in this. What that did was it didn't exactly help me, because the model didn't quite pick up on these examples. Maybe it is very very model dependent. And I've used Mixtral for everything. Mistral and Mixtral were my top choices. OpenAI is good, but the problem is you can't run that locally. And guidance works a lot better if you have a local model. In this particular technique, I'm just telling the model to reduce the false positives. So if it says reject, I ask it, hey, are you sure about this? And it generally said yes, but there were times when it said it wasn't sure. And that allowed me to reduce the number of false positives. In the next classification task, I just reduced I reduced the steps and increased the number of classes. So instead of asking for accept, unsure, reject, I said accept, unsure, and then gave it a bunch of reasons for rejection. And this it started working better than the previous one. The accuracy was comparable, but the false positive rate was a lot lower, which is what we were shooting for. Now here's the fun part. I specifically asked the model to pick out the problem and the proposed action and how many ideas in each comment, because this is exactly what the moderation is about, finding what's relevant, what's not. So if a comment comes in and doesn't bring a problem, doesn't bring an action, it's just complaining about something that's not even important, that's noise. But if there is some specific problem being mentioned or some action, then we could separate the signal from noise and improve the SNR. Pol.is also, the moderation guidelines said that each comment should introduce one idea. So asking the model to spell that out before making a moderation decision, this helps it do better with how it moderates. So in this case, model actually started deliberating about what the problem is, what the proposed action is, and this turned out to be it looked very convincing to me, at least. And this also helped me minimize hallucinations, because what it was saying was making sense so far. I haven't been through the entire data set by hand, so this is just my high-level perception. And I'm going to publish all the data sets for this, or all the generated data. Here's different configurations with different sets of techniques that I tried, and some work better than others. Now, jumping onto the fun part, the topic modeling. The idea is to use UMAP to reduce the dimensionality, then feed it into HTB-scan for density-based clustering. Once it clusters, it identifies the areas of high density. That's the hot topic that people are talking about. Feed it into a vectorizer, identify the most important keywords in each topic, and then feed them to a language model and get labeled for each topic. Just the basics of UMAP. I did some optimization. To be honest, it wasn't great because it's very dataset specific. So different datasets would require different type of variables. It's a manual process. I don't think there's a straightforward way to say what works for every dataset. HTTP scan was pretty simple. I stuck with the default values mostly with some optimization, but the library is it's a great library. The term frequency, inverse document frequency is the standard algorithm. It's on Wikipedia. I think I've linked it here. Yes. So it's a count-based vectorizer that takes your word, takes a bag of words and counts the frequency of that word in the overall document and in every cluster and picks out the ratio of it. The actual equation is a little more complex. It uses logarithms to identify the weight of the word, but this is just the basic idea. And I also use spaCy, remove the stop word so we get improve the SNR again. Now argument generation. The idea, when I say argument, I'm talking about an actionable insight that actually addresses a problem and specifies what needs to happen to alleviate that.
Can I ask you a question about that?
Yes.
Okay, so my understanding, tell me if this is correct. So the argument in your framework is kind of like a proposition of some sort of solution, and then like kind of like step by step what needs to be accomplished in order for the solution to solve the problem. Is that right?
Not step by step, but yes, exactly that. It's just a proposition saying what needs to happen.
Okay, thank you.
I did not want the LLM to come up with any answers. I didn't want it to hallucinate or make up things or even use a knowledge base. I just wanted it to interpret the data. So what I did was ask for a set of areas of improvement. I did do some filtering to make sure I'm not feeding every single argument into the pipeline. I'm only feeding the ones that are generally upvoted. So there's different thresholds for that. But once I got that, I asked the language model for a list of areas of improvement. And with that list, I went back and said, for this particular area of improvement, give me the problems being discussed, and then give me the solutions being identified. And then I combine those and then ask the model, hey, here's the problems that were listed, here's the solutions, now give me a set of actionable insights based on these. So just breaking it down step by step, building a chain of thought in a sense, helped minimize the language model's own creativity, and it allowed me to just synthesize what the people are saying. Now, once I had those insights, I had a scoring mechanism. It was fairly simple, but it was a way of calculating how much support each of these items has. Because these comments, so here's a little example here. The comments in the middle level have voting data. I know exactly how many upvotes and downvotes they have, and I also know who's upvoted or downvoted each of them. But these arguments are just things we came up with ourselves, so we don't exactly know how many people supported. Now, if I just look at every comment and say, these are the comments behind this argument, so, and I add the votes, that doesn't exactly translate well because there's a lot of biases in the data set, and also some, I'll talk more on the next slide about it, but some comments, or sorry, some arguments would have a lot of comments underneath them, others would have fewer. So how do you articulate how much support each argument has, or how much, what the acceptance is for each argument? So for that, first I asked the model I gave it every possible pair of argument / comment within a topic, and I asked, are they related to each other? Is there a support or refute relationship? And anytime the model said yes, the argument or the comment looks like it's supporting the argument, I registered that. And then I went back and counted the number of people that support a position, or they're likely to support a position. So it's not the hard count of the vote, the votes they have on the comments. But for each comment, I looked at who's supporting it and then approximated how many people would want to support that argument versus be against it. So in this particular example, there's 3 people that tend to support this and 2 people tend to refute it. So it's 3 versus 2. Now, if a person voted positively on one comment and negatively on the other comment, then they're not going to count in favor unless they have upvoted at least half of the comments. So that's the threshold I'm looking at. There's a risk for biases, like I mentioned. A bunch of comments will, especially anything that was posted early in the conversation on Pol.is, would receive a lot more votes just because it's been there longer. Now, Pol.is does mitigate that by surfacing newer opinions more often. So newer votes, newer comments with fewer votes will appear more often, but it's still very hard to balance. Some topics are more popular and people want to comment on that. They, Tim, are you saying something? You're muted.
I think he's been caught in another conversation. Go on.
Oh, okay. All right, never mind. There's controversial topics that get very heavily downvoted. When people talk about marijuana, for example, in this particular data set, those arguments or those opinions did not have a lot of support, and there were some valid opinions, so I don't want to suppress them. So for that, I just filtered within each topic by quantile. So in this case, I just dropped the bottom 10% of the comments to make sure I'm filtering noise to some degree, but at the same time, not just filter half or more comments or so on. And then some people tend to vote more often than others. So for that, we just looked at how we're counting the individuals and not exactly a hard vote count. Now, once I had all that, once I knew which arguments being supported by what comment and so on, I use argdown. Are you familiar with argdown, or should I go over it real quick?
Please go over it.
Okay. So it's a very simple syntax. It's based on Markdown, and if you know Markdown, you can do argdown within it's just the same thing, except they add a few more constructs. First is a statement. You specify a statement using these square brackets. And anytime you have this label, you can add text to it, any amount of text, and that will appear on the map. Then there's a bunch of pluses and minuses, which are pros and cons. So for any statement, you have pros and cons right there, and then you have an argument listed in these the angular brackets or the less than greater than sign. So you have those, and then you can also specify relationships. You can support, refute, and there's multiple types of relationships. I kept it simple here. And then, of course, the headings and so on. You can keep those, and these appear on the map. Now, this is a live widget. It's a web component. So when I click on map, it actually renders this way. And this is what it looks like. So this helps you generate some really complex structures, and you could do a lot here. Let me see if I could pull another example. Map. And here's a more complex example that gives you an idea of what argdown is capable of. But the beauty is that you just have to specify everything in plain text, and this is very easy to generate using a simple grammar generator. So in my case, I wrote a grammar generator that it was a set of Python functions that allowed me to generate argdown very quickly. And this is all going to be published on the repository. If it's not already there, it's going to be Apache too, so anyone can use it. Now, went over comment moderation. I don't think there's anything really interesting here. The only thing I'd say sticks out is that the chain of thought helped, and the deconstruction technique, when we ask for specific problems and solutions and within each comment before deciding, it helps the model do better. But user examples was not helpful, and chain of thought by itself did not seem to help very much. It helped when I paired it with deconstruction. So if I just say, give me your thought and then give me a decision, the model became more sure, but it wasn't, actually, no, it became more unsure of its decisions, but it wasn't very helpful. This is just the topic modeling projection of how I reduce the embedding. The topic distribution. There were a bunch of outliers in the very first attempt, but well, anytime I ran this on any data set, there were a lot of outliers because that's how HTTP scan works, and that's okay. Now they're not noise because noise has been already filtered by moderation. So I still included them. So for every outlier, I looked at the nearest cluster and associated with the clusters based on embedding. Here's what the map looked like initially. And this is a live interactive map on the website. So it's the same one that has the slides. I'll post a link directly to the site. But there's a bunch of notebooks and there's information on that. So you can play around with the map and even click on each of these dots to see what the comment is and why it belongs to the topic it belongs to. The gray ones are outliers here, and the next one, we get rid of the outliers because we assign them to every topic. When you assign those outliers, the topics change because now every topic has more comments, so it's not the same topic, or it's not exactly the same anymore. So the labels change as well, and the placement of the map shifts and so on, and that's expected. The hierarchical structure, it tells us which topics are close to each other, and it allows you to merge the topics if you want. So say if you thought this traffic management and pedestrian topic were the same thing, just happen to be split up, you could go back and merge them. So but topic is awesome for those things. It gives you an easy interface to do all these things. Now here's the fun part, the map that is generated. I'll zoom in before I zoom in. So the top level is the topic that's being discussed here. The middle is the synthesized arguments based, and they have a little robot saying they were AI generated. And the bottom layer is the comments posted by real people. So in this particular case, 719 votes, these arguments and comments have a many-to-many relationship. They're not strictly tied to one argument, and comment could be anywhere. Also, there were a lot more comments per topic, and there's a lot more arguments generated because for a data set of about 600 something comments, I came up with 102 insights or arguments. And that was within these sets of topics that we have. I think it's close to 15. So there's a lot of arguments. Not to approximate the public support, I considered every single comment that was out there. But to show on the map, I had to limit it down to the best ones. So that's where I applied the filtering. So not everything's shown, but the numbers still include every comment that's out there. So you see 719 votes here, 800 something here, 300 something here, but they don't add up because these are the voters approximated, and this is the percentage that tends to agree. So when you pick the arguments that have the most agreement behind them, or most acceptability behind them, that gives you the things that people tend to care about more. And for a policymaker, I think that's interesting. Here's another one. Different topic, but same idea. Any questions or comments so far?
Just want to put that in context. In a way, this is use case of what we've been trying to build, which is deduplication, right? He's taken the comments and got the LLM to generate argument from many comments that look similar, or basically he's trying to get the LLM to extract the arguments. We'd call them claims, I think, that can be extracted from many common comments. So it's a form of deduplication. I think that's should be of interest to this group.
Is that what it's doing at the comment level? Because it's each comment has a number. It's a specific comment and it's got its specific votes. Is it actually synthesizing multiple comments into one?
Yeah, the purple are basically, you remember, I don't know if you remember the earlier slide when he said break the comment into here's the proposal and here's the description of the problem, right? The decomposition slide, that was very early on. So he's asking the LLM, break it down into, yeah, what's the
But
problem?
so what you're saying is the deduplication part was the part in the middle that is the like synthesis of the proposal or the solution.
Each comment is broken down into problem action. Actually, maybe I'm less than clear myself about how problems and actions are deduplicated. Maybe you, Sonny, you'd like to go over that again.
Yeah, so this set of slides had to be condensed within 45 minutes of my presentation, so I had to not get into too much technical detail, but the notebooks that I have on this probably be a little more insightful. So while generating arguments, here's the prompt I use. So first I ask it to identify unique areas of improvement, and then for each of them, give me a list of associated problems and actions that people are asking for. And then using those, create short, convincing one-sentence arguments. And I broke it down into steps, so I didn't do it all at once. So first was just give me a list of 8 most important areas. So got that. And this is within one topic. And then I started throwing those areas of improvement one by one at the model and ask it, what's the problem being identified in that area? What are the solutions? And then give me an argument. So for each area of improvement, it gives me, I create one argument part. So this is somewhat deduplicating, but at the same time, yes, there were some things that were repeated. It kept creating the same argument over and over in different words, which is okay. That could be filtered at a different time. So I didn't do much filtering there, but at least I was trying to capture what people are saying without much hallucination. So the idea was to extract information and just interpret that.
So going back to that diagram we were on in your presentation, the 3 levels.
Or are you talking about? Oh no, that. So yes.
The examples of the topic and then
Okay, got it. That one. This right here.
Yeah, like this. These comments are comments that were generated by the LLM.
The
No,
bottom level.
that's the raw data. That's the raw.
That's what I'm saying. That's what I'm saying. These are not deduped. It's the part in the middle that is a deduplication of those comments, basically.
I wouldn't say deduplication. I'd say interpretation of them. So there could still be duplicates, and there's still a lot of people saying different things.
Yeah, maybe I was misleading in talking of deduplication. What I understand now is that you give a bunch of related comments. You use the system to group comments under broad topics. And then you feed all the comments relative to that broad topic to the LLM and say, give me the proposals from there. So it's not
right.
And that's a way to how do you keep the association to the comments is now something I'm curious about.
Yeah, that was the fun part. So to determine the relationship, I had another set of prompt and task for the model. I gave it one argument and then one statement at a time, saying for this given argument, does this statement support, refute, or is it unrelated to the argument that's above?
Okay.
And this seemed to work pretty well. I was surprised because I wasn't sure if it gave me good data, but there were only 17 refutes in the entire data. And for this, the number of comparisons explodes because for every argument, for every statement, you're doing a lot of comparisons. So I cut that down by saying within a topic. So for each topic, I did that check, but it was still about 5,000 pairs of arguments and statements. This was the most compute intensive part of the pipeline, which is okay. I still had the compute, so no issue. There were only 17 instances where it said it refutes that particular argument, and a lot of those were not true because it was a double negative where the language model got stumped and couldn't do very well. Jack, you have something.
Yes. it's slightly off topic to what you just said, Sonny, but Tim opened, the closet to the real ghost in the room, and that's that the way people talk, it's very hard to deduplicate. If you the canonical example I gave in my thesis proposal was if I ask you what causes climate change and somebody says CO2 causes climate change, and somebody else says climate change is caused by carbon dioxide, native English speakers know they said the same thing, but the computer wouldn't have any idea. String comparisons and even language models wouldn't spot that.
Language LLMs would now.
They
would have
might.
similar embeddings. Yeah.
I think embeddings might work for that. Yes, maybe,
so-
but not very effectively.
Yeah, so that was how Open Sherlock got invented, and I was well on the way to defending my dissertation and being a full-blown PhD when health issues stepped in. But Open Sherlock, what the prototype of Open Sherlock was, it used topic map tools that I was evolving to normalize the statements, so that you actually create a canonical triple out of those two claims, and it would be the same. It's CO2 caused climate change, and that's sufficient to say they said the same thing. So that was the basis for Open Sherlock. I'll stop there.
It makes me wonder if LLMs could be used to generate those triples, and if it would do it consistently.
We've been working on that. Yes, they can do it. Can they do it consistently? Probably not yet. But there is an interesting library that we recently tried and it worked well. So I'll link to that here. I'll drop it in the chat.
I've had there's a GitHub repo for something called Papers to Text, and it uses Chat GPT, and it will reduce a paragraph down to a JSON object with all of the claims in it, and it's pretty accurate, but it doesn't canonicalize them. It gives you what they said. You can then do further processing, but again, it uses Chat GPT, and I'm congenitally opposed to using Chat GPT when I have open source language models that can do the same job.
Okay,
Mark,
well, so we can close parentheses on that. Thanks for answering those questions for me.
no problem. Mark Antoine, you were asking about specifically how I figured the relationship. Does this answer it?
Yes.
Okay.
Thanks.
So yeah, that's how I ended up creating these. This is not the most effective way to do it. It was the most expeditious way because I had to finish my thesis by that date. But now that I'm free of that, there's a lot of ideas I'm exploring. So I'll jump to the future work here. And this is just a brief list. I wanted to put like 10 things there. My advisor told me not to. This extraction and reasoning we did, in the end, that could be done during the discourse when somebody is posting a problem or a solution in Pol.is. Why not just have an LLM look at it and say, is this the problem you're talking about? Is this the solution you're proposing? And maybe just help them. So like a coach, maybe. That's one. The other thing was everything I did was contained within the topic. So if once I've segmented those comments into different topics, there's no connection between them anymore. And I know there's a lot of comments making claims here and other comments making different claims here that are saying the opposite thing. It would be helpful to identify those claims. We don't look at the contents of these comments very closely, and we don't extract any of the claims, and that's something one of the committee members brought up too. So that's something I'm interested in. And then Kialo is another platform, but that's a debate platform. So different construct. It'd be nice to generalize some of these techniques there. So thoughts? And on my end, I think this is all I have. So it's open discussion now.
Will say that's all very interesting, and I'm probably going to want to go and take a closer look at some of your slides. So thank you for presenting.
No problem. And I'll continue developing these. I'm not done with the project, and the website will continue to evolve over the next few weeks or months, maybe. So we'll see. Yeah, but yeah, keep following it. Also, there's a GitHub repo with the website that has all the code.
The generalizing techniques to platforms like Kialo, is that, are you saying like generating something like Kialo from general discourse, or you mean analyzing Kialo? And because it seems Kialo is more or less its own argument map structure, right? So it makes more sense to be recreating something like Kialo based on general discussions. But what are you thinking there?
I'm thinking more so of analyzing what's already on there, because Kialo has a lot of discussions and a lot of maps. So I've pulled some of the data sets, but it's a massive repository. So just analyzing that, and also maybe turning that into an IBIS tree would be more helpful. So IBIS is not something I've done enough with here, because that's what I try to base off of, but I deviated from IBIS, and that would be nice to build a larger tree with smaller nodes.
It's not full IBIS in part because there's no new questions, and for me the new questions are really important in the iteration process. But still, what it does show is that it's possible to say, here are comments, here's a structure we want. Can we can ask the LLM, what can you see that fits that structure from those bunch of comments? It's not exactly surprising that it's possible, but it's interesting to see it working well enough. Moderation, the first part of your presentation was the moderation thing, which what was interesting is also being able to say, oh, this is not a good comment because there's too many ideas and they need to be distinguished, yada yada. Again, I mean, in a community context, it could be helpful to help people get better input, better structured input. But I think what's really important is also being able to rephrase in a way that is well structured. Like I know there's all these activities we want to do. The application is one, but all the work of seal manning, for example, that Society Library does. Knowing how to get more structure out of unstructured or semi-structured data is what we're all trying. And this is a interesting aspect. The other thing that I think was interesting to me is that you got it. We've all done clustering. Recomposing the clustering labels is something I've always found very iffy, but those did seem to make sense, those you showed us. So I am curious to dig more. I'm surprised something as simple as TF IDF worked, but the last step I'm a bit obscure on. But what do the clusters mean really? And by the way, did you map the constructed arguments to the clusters? Do they map to the clusters? Because the clusters are the original comments, right?
They're contained within the cluster, so I keep it. So the comments I pull are from within that cluster or topic, and I don't mix those clusters. So once they're separated, they stay separated, and that's something that could be improved upon. But what you said about the better structuring, yes. Initially, my thought was to, for each topic, just feed all the comments into a language model and ask it to frame a question that address those things. So it is possible to frame each thing as a question and then force that IBIS format. But at that point, I felt that I was just asking the model to create new content, and I wanted to be very careful of that. I think interpreting text using model is more interesting than asking it to create things, because it'll create all day, but that's not necessarily useful. Yeah, that's yeah. Topic modeling is largely based on what topic told me to do. I just went through the documentation and followed the best practices. I did define a lot of those. I didn't follow the defaults, of course. I created different types of models. Even for UMAP, I did a lot of optimization, but I used language model in the end to. I can show you the topic representation part of the language model. So once I had the labels for each topic, I fed those to the model and said, here's the keywords, here's the example comments. And this was, again, based on per topic, saying these are the most representative comments of the topic. So I gave it those and then said, give me a title. And I ran this with 3 different models here, the Mixtral, Mistral, and Llama. And actually, no, I did GPT-2 as well, just for the sake of it. And GPT-2 output was bad, but it was still worth looking at. Also, GPT-2 can only take so much before it runs out of memory because the context window is very small, but it's worth trying out. So yes, this was the idea. But the most important thing right now is I'm looking at what's next. And there's all these different ideas. And I think another big one that came up, and that's something that we've been working towards, is bringing evidence into the platform. So when someone's making a claim, they should be able to import evidence from outside and say, this is why I think that this should happen, and so on. So that would take this argumentation to the next level.
That's excellent. Can I ask a question? And I apologize if you covered it. I just had to pop out for a second, but now I'm back. It's related to like that aggregating up, summarizing, abstracting of comments, which is like what we found. Well, just to give you a little background on how the Society Library does it, we extract arguments, claims, and evidence from artifacts, in part because we find that like sometimes you can get higher levels of precision of argumentation. And when you look at like different forms of media, like news articles and like popular media, where like the audience is the general public, when arguments are made in like news articles, or I've looked at like at a lot of Pol.is data, and they tend to be just as vague. That's kind of a problem when it comes to like deliberations. So, for example, like the statement nuclear waste is dangerous is kind of like meaningless in a way. Because like, what are we talking about? Are we talking about licking it? Are we talking about long-term storage? Are we talking about the casks in which they're contained? Are we talking about potential leakage of it? So like what we find is that, you know, even down to like propositions about solving an issue, like sometimes you have to get meaningfully precise in order to deliberate its truth or deliberate about what to do about it. And so I'm just wondering, have you done any experiments about taking public comments that may be very vague, so much so that they are like sufficiently like not really like deliberatable, or like evidence may be misapplied to it because of the comments vagueness, and then making it more precise so that it could actually be meaningfully discussable?
Pol.is is a terrible platform for that, because Pol.is limits you to 140 characters. It's a tweet, so how much can you say?
Right.
So I've seen a lot of that on Hacker News. Somebody would come post a discussion comment and they'd be vague about it, but then another person would come back and follow up and say, what do you mean? What are you specifically saying? So that's where I see a lot of that. Now, I haven't done much with it, but that's another data set I'm really interested in, is Hacker News, because it gets into the depth.
Right. Question for you. Would you be interested in doing any like work with Society Library data? Like these days we've been fine-tuning models to generate argumentation based on our work modeling deliberations at the societal scale by hand. And it would just be really interesting to see it kind of like worked with a little bit, especially like parsing out issue statements and then propositions about solutions. So I just want to see like how I mean, you have specific data sets in mind, but are you open to doing experiments with other kinds?
Definitely, yes. Yep.
Cool.
Now, anything I'm looking at here is there's so many potential directions, but I'm still figuring out exactly which one's the most beneficial, because I can't do everything. I understand that, but
right.
I'm always looking for interesting problems to solve. Yes.
When you say you're going to keep working on this, is this through UCF? Are you continuing study there, or is this with the military, with the government, or which way are you going to keep working on this?
Good question, and brings me back to what you said initially about my work with the military. So UCF, I'm done here. I'm graduating and I'm heading up to New York here in next month. In the military setting, I'll still be in an academic setting and continue doing that for the next 3 years. So my interest here is academic, mostly just furthering the research, furthering the field. So that's my primary motivation. Now, I don't think the government does enough of debate mapping and argument mapping and really looking at it that way. Whatever the government does is in a different context, which a lot of that happens behind closed doors, but I still don't think it's happening enough. And I think it's a wonderful opportunity. So this is something I'm looking at bringing into the government settings where possible, where it does make sense.
Right. That's the point of governance in a nation of the people, right? Is to be able to bring the discourse together and actually make efficient and effective decisions. So we definitely need a lot more of this kind of work.
And unfortunately, the information landscape has become a war landscape, and getting the defense involved in that is absolutely primordial. And from what I understand, there is awareness of that.
400%. There's a specific discipline for information operations, and they work with a lot of these things. But there's a lot more to be done. There's plenty of opportunities there yet.
Well, we're a little bit past the top of the hour. Might be a good time to close down the meeting unless anyone has any burning questions or announcements. Awesome. Well, thanks so much, Sonny, for jumping in. You're currently, of course, welcome anytime to any of our meetings, and look forward to, seeing what you come up with and collaborating where possible.
That sounds good. Thank you for inviting me. Thank you for having me over.
I'm glad you could make it. Thanks for. I invited him very much at the last second. I thought, this. I saw the defense, and I thought this will be of definite interest to this group.
Yeah, it was a great idea. I was very glad to have you here.
Thank you.
Thank you very much, and see you all in our next session. So, ciao, ciao.
All right, good to see y'all. Bye-bye.